Highlight preview of the technical presentation of Denis J. Gendron, CTO Claire Lasers. Why QOR by Claire Lasers for oil refinery?
Over the last decade, the combined news of depletion and drastic observed consequences of ongoing climate changes led the investment community to divest massively and to devaluate crude oil compared to its fair market value, given its current growing demand.
While the century-old problem associated with growing greenhouse gas emission is generally accepted, its resolution has been further compounded over the last 10 years by misinformation regarding readiness of alternative solution. Ensuing chaos and confusion led to oil divestment. Abandoning the industry of mined hydrocarbon energy spells dismay for power-hungry processes, like freight transportation. These are hard process to maintain and to rebuild. While the problem had obviously worsened, the return path to a thriving economy has also been made longer, at least for America. We are glad to introduce QOR as the best option to reduce greenhouse gas emission, and the only way to meet the Paris target. QOR technology is built on a strategy supporting the growth of electrical transportation. Sarnia is a site of predilection, as an official launch site for QOR 2022 marketing project. We hope to build up supportive interest by a team of industries, possibly directly as working partners. We are going to Sarnia to meet the members of the refinery industry, and to build teams of interested collaborators. The original instigator of the QOR project was an operation manager at the Suncor production site. As a key player in the Sarnia community, and a senior Suncor engineer, he influenced me to start this project 25 years ago. Suncor in Alberta indicated that they would be willing to support. Over the last 20 years, Claire Lasers Corporation has been part of a cottage industry developing laser material processing applications, such as laser marking and laser micromachining. Claire Lasers devised many other applications, such as biomedical energy and security applications. The QOR project has been a pet project for the Gendron family for over a decade. You can see him with his son working on one of the components of the system, back almost 10 years ago. Claire Lasers devised many three innovative technologies as a necessity to solve the problem of QOR invention: conformal heating, laser heavy cracking reactor, and high-precision vacuum compressor. Dr. Gendron combined his 25 years of experience developing practical application of applied quantum electronics to devise a better oil cracking process for refinery. Laser heavy cracking, or LHC, to surpass fluid catalytic converter. LHC is a key component of QOR, quantum oil refining. To illustrate how application of quantum electronics benefited society, it simply suffices to contemplate these patterns of evolution, enabled by quantum science and quantum engineering for established technologies. The second half of the 20th century witnessed replacement of vacuum tube with transistor. At the turn of the 21st century, incandescent light gave way to semiconductors light sources. In the same line of thoughts, Dr. Gendron, CTO of Claire Lasers, applied quantum electronics to improve the efficiency of industrial processes. Claire Lasers devised the LHC and QOR process to enable using quantum for flexible fuel production with reconfigurable branching ration. Since its inception in 1867, Canada has a tradition of innovation. From the original railways project across the North American continent, to the development of telephone in 1876, to the first airplane in 1903, Canadian history is paved with innovations, such as telecommunication. From that perspective, I am only doing my humble contribution, as our nation have a tradition to uphold. Thanks be to God to have the privilege to live in these times. Thank you for your support.